Hello, my name is Isabella Merritt, and in this short video I will present my poster on the photoisomerisation of cis-azobenzene. Azobenzene is one of the simplest photochromes, with the isomerization between cis and trans forms controllable in both directions using light. One of its most interesting properties is that the photoisomerisation quantum yield is dependent on the wavelength of light used to excite the molecule. Exciting to the higher energy pi star state results in lower quantum yields than when exciting to the lower energy n pi star state. In our study, we aim to use surface hopping non-adiabatic dynamics to reproduce and explain this reduction in photoisomerisation quantum yield. In our dynamics, we are able to reproduce the quantum yield reduction of around 0.1, which is measured in the most recent experimental studies, which had questioned previously measured yields. The first thing we tested was whether the mechanism for quantum yield reduction discussed in literature for trans-azobenzene could also explain the reduction seen for the cis isomer. In this mechanism, the decay from S1 to S0 occurs earlier along the rotational isomerization coordinate after exciting to the S2 state. However, when we plot the positions along this coordinate of our hops from the S1 to S0 states, we see that the average decay is around 90 degrees after both excitations. We therefore studied in detail the trajectories in a range of coordinates, and found that the reduction is instead due to different probabilities of following a range of deactivation pathways, which are available after both excitations. The main reason for quantum yield reduction after excitation to S2 is due to a fraction of photochromes, which after S1 excitation directly isomerize to trans-azobenzene. After S2 excitation, these can instead become trapped in the S2 state around a central dihedral of 90 degrees, and from this point can form either the trans or the cis isomer, thus reducing the yield of trans-azobenzene. To conclude, we have been able to use semi-classical non-adiabatic dynamics to both reproduce and explain the wavelength dependency of photoisomerisation quantum yield in cis-azobenzene, identifying a mechanism different to that seen in the trans isomer. Thank you very much for watching my short presentation. A link to both the PDF version of this poster and the full article on this work can be found in the video description.